Welcome to the Podkey summary of Speedrun Your Game Port with Agentic Coding from WWDC 2026. Today's big thread is game porting, and specifically how Apple's updated Game Porting Toolkit is trying to make AI coding agents actually useful for real platform work. The interesting part isn't just that it writes code faster, it's that it bakes in platform knowledge, debugging habits, and a structured workflow so the agent can avoid the kinds of mistakes that usually eat up days in graphics work. And the payoff looks bigger than a single demo, because the same approach was used on Godot to stand up a Metal 4 backend in just a few days, with humans still steering the architecture. The headline is a new set of expert skills and workflow skills for coding agents. Those skills give the agent platform-specific knowledge, especially around Metal 4 and macOS graphics behavior, so porting work can move a lot faster than doing every step manually. What makes that matter is quality. These skills don't just point the agent in the right direction, they also encode best practices and warn against common anti-patterns, which means less babysitting from developers and fewer messy surprises later. The porting assistant itself follows a pretty clean three-stage flow: discovery, milestone planning, and validation. At each stage, it automatically pulls in the relevant expert skills, so it's not guessing from scratch every time it hits a new problem. The milestone setup is especially practical because the work stays incremental. The agent can carry context forward across sessions, keep track of what it already learned, and continue the port without losing the thread halfway through. One of the strongest ideas here is anti-pattern detection. Each expert skill checks generated code against a library of known porting mistakes, which cuts down debugging time and helps the code start from a sturdier baseline. Then, during validation, the assistant compares the results against ground truth captures from the evaluation environment. So instead of waiting until somebody notices a broken frame deep into testing, it can catch deviations much earlier. A lot of these skills are aimed at the bugs that are annoying, precisely because they don't fail loudly. Take Metal 4 resource residency on Apple Silicon. There's a dedicated skill that teaches the agent to register GPU resources in a residency set before using them. If that pattern is missed, the GPU can't read the textures correctly, and you can end up with silent visual errors. No dramatic crash, just the kind of wrong-looking output that can steal your entire afternoon. There's also a shader pipeline skill for converting D3-D12 root signatures into Metal 4 argument buffer layouts. It uses the Metal Shader Converter runtime to query the right offsets, which matters because bad offset math might still compile just fine while quietly mangling the rendering. Another skill handles synchronization, mapping D3-D12's barrier model onto Metal 4's producer-consumer model with stage mapping tables for resource dependencies. That's the kind of detail where a lazy fallback can seem okay in a simple scene and then break in more complex pipelines. Blanket barriers might get you through a demo, but they're not a real answer. macOS 27 adds new command line tools called GPU Capture and GPU Debug, and this is a meaningful upgrade for agent-driven debugging. The agent can now autonomously record GPU traces and inspect resource bindings, which earlier agents really couldn't do in a systematic way. That lets it work backward from a visual symptom, like bad lighting or missing textures, toward the actual root cause, instead of flailing around with random edits. For graphics debugging, that's a pretty big shift. It turns the process into something more methodical and a lot less mystical. There are also separate expert skills for integrating MetalFX upscaling and frame interpolation. On the upscaling side, the agent gets guidance for temporal configuration, including jitter scaling, motion vector conventions, and history reprojection, which are all small-sounding details that can make the image either stable or strangely haunted. For frame interpolation, the skill adds a dedicated present thread and the timing needed to interleave synthesized frames without increasing input latency. And then there's a nice feedback loop with Metal HUD extensions in macOS 27. Those expose things like jitter sequences, exposure parameters, and motion vector scales, so values can be adjusted live. Using those overrides, the agent was able to resolve wobbling artifacts and blurred textures much faster, which is exactly the sort of hands-on tuning you want when a frame looks off, but not obviously broken. The bigger takeaway is that this isn't being pitched as a neat trick for tiny samples. The same skill set was applied to the Godot engine, where it added a Metal 4 backend alongside an existing Metal 3 backend in just a few days. That's a useful proof point for scale. It suggests agentic porting can help with serious engine work. As long as humans are still making the architectural calls and the agent is doing the heavy lifting inside a well-defined process. That balance feels important here. This is less about replacing engineering judgment and more about giving that judgment a very fast, very specialized assistant. So the story here is speed, but also discipline. Faster ports matter, and faster ports that don't quietly smuggle in graphics bugs matter even more. If this approach keeps holding up on real engines, a lot of platform work could get less tedious and a lot more tractable, which, honestly, sounds like a pretty good use of an agent. This episode was generated by Podkey. Create your own at podkey.fm.